Okay. So this is the practice test for Unit 3 that I printed off. I'll try to upload this into Canvas as well, but this is version 1. I do have a version 2 in class, so if you want to come see me on Monday, you're more than welcome to come by and we'll take a look at that. Okay, this first one is asking for the equation of the line. So easiest one to work with is slope-intercept form, which is y equals mx plus b. B is our y-intercept. So our y-intercept is right here, so it's a -2. So I know that this is something x minus 2. I still got to find my slope, right? This is my slope. And we find that by doing rise over run. So we go find our next point that it crosses through. So I would say it's about right there. So I've got to go down 1 and then right 3. Or right, how many is that? That's 4, plus 4. So my fraction or my slope is going to be -1 over 4 minus 2. There we go. Okay. So the next one here says population of a certain town is increasing linearly each year. Population at time T4 is 1,600, and then at a time T8, so is 2,400. So what we're looking at is this is kind of our X value, or our left to right, and this other one is our Y. So we can call this X1, Y1, not 2, and then this is X2, Y2. So if we write this equation, once again, we want to figure out where the y-intercept is and the slope. So to find slope, the general form for slope is m equals y2 minus x2. Nope, y1 over x2 minus x1. Now, honestly, it doesn't really matter which one you use first, which one's number 1 or 2, so don't worry about that too much. But we do have this one here. So m equals 2,400 minus 1,600 over 8 minus 4, and that's going to give me that 800 over 4. And so if we simplify that, m equals 200, which is great, but it doesn't give me the full answer. So once again, I am working with y equals mx plus b, and so we don't have b yet. So we can use either x or y value for this next one. Let's just pick this one. So if I have 1,600, that's going to equal 200 times our x value, which is 400. And then plus b, so that's our variable. I get 1,600 equals 8. It's not 400, it's 4. So we minus 800 minus 800. So we get 800 equals b. So now we can write our full equation. And the other thing we need to deal with, I was using x and y, but it is in the form t, so let's use that as our variable. So I'm going to have p of t, which is already written. We don't need to write that one. And that's going to equal 200 t plus 800. There we go. So number 2. Sweet. Okay, number 3. Okay, truck costs $80,000. Depreciates $7,000 per year. Write a linear model in this form, v of t, mt. So you make sure, once again, we use t for time. And the idea is this truck, when you buy it, okay, in the graph is going to be all the way up here at 80,000. And it's going to go down. And if I go over 1, so 1 year, wherever that is, it's going to be 1 comma, and then we go down let's say 7,000, so that's going to give me 73K, 73,000. So if we look at our slope, our change of slope, it's going down 7,000, so it's a negative 7,000. And then it is a t value, that's kind of our x. And then we're adding our y-intercept, which is right here. That's our b value, where it crosses the y-axis. So that's kind of where we started. So that would be a plus 80,000. And there's our formula. Okay, after 3 minutes, the submarine has descended to negative 530 feet. After 7 minutes, the submarine is descended to negative 650 feet, assuming a linear function. It means it's going down at the same rate. Write an equation. So once again, this is kind of our x value, or really in this case, it's our t. So we've got one that's 3 minutes and you're at negative 530. And then your other one, you're at 7 minutes. You're at 7 and you're at negative 650. And so those are our points, okay? So it's just writing our linear function, the same thing we did. So we need to find our slope. So we'll call this x1, y1, x2, y2. So we got negative 650 minus a negative 530 over 7 minus 3. Minusing a negative is a positive, so negative 650. So that's negative 120 over 4. So my slope is negative 30. And then I need to find my b value, which is my slope intercept. So let's come up here. So use either one of those equations to plug in x or y. I'll just use the first one. So I've got negative 530 equals negative 30 times my x value, or my t value is 3 plus b. It's negative 90 plus b, 30. So now we're going to add 90. Add 90. I think that's 440, negative 440. Well, I'm just putting it into my calculator. Yep. So negative 440 equals b. So now we have our m and our b. So we got, remember it is in terms of t, not x. So just be careful of that. My slope, so I got negative 30 t minus 440. Just want to plug it in. Okay, so now we're getting into radicals. Couple ways I could do this. I could split this up into square root of 16 times the square root of q to the 42nd power. Square root of 16, we can do it this way if we want, but there's our exit buddies. So we've got 4, and then if I wrote all 42 of these q's out, I could make 21 pairs, or 42 divided by 2, which is our index. It's our square. That's where that's coming from. So that's going to give me 21 with no leftover. So my final answer here is going to be q to the 21st power. Okay, let's move on to the next one. That's 5, so now we're going on to 6. So what it wants us to do is it wants us to simplify. So we're going to take 648. I'm going to do this the long way. And I know, and I have my calculator with me, I know that 648 is an even number. So I'm just going to divide it by 2. 2 and 3, 24. That is also divisible by 2. So 2 and 1, 62. Divide that by 2. 2. That's divisible by 81. 81 is not divisible by 2, but it is divisible by 3. which is going to be 27, which is 3 and 9, and then that is 9, or 3 and 3. Okay, so I know that I'm doing a square root, so I got to do groups of 2. And then I have my lonely loner right here. So he's staying under the radical. So I got 6, and then the 2 times the 3 times the 3 is going to be 18. And then I got a root 2. And then both of those are being divided by 3. If you want, you can just write them as separate fractions. That's okay. We have a common denominator. So that is 2, and then 18 divided by 3, so it would be plus 6 root 2. And that's my final answer. Okay, let's move on to the next ones. All right, when I add and subtract radicals, I have to have the same index. And here I have the same index. Okay, these are all square roots. Okay, but I also have the same radicand, which is the number under the radical. And right now I don't, but chances are I will be able to. So the 8 will split up as 2 times 4, which is 2 times 2. So I can take out one group of 2s, so that gives me 6. I'm a lonely loner. There's not a q I can take out, so it's going to be 6 root 2q. So this is 9 and 2, which is going to be 3 and 3. I need to give myself more room. Okay, so I got 6, and then 2q. So got my 3, but there's this negative 7 that's already there, so I'm going to have minus 21 because I multiply those times 2q. And then I know this is 16 and 2, and this is 4 and 4. I could go to more, but I already have a pair, so I'm going to just use that. And that 4 is going to multiply the 5, so I got plus 22q, because I got some lonely loners here. That's where those came from. They stay under the radicals because they don't have a pair. Now I have the same radical, same radicand, same index, everything. So now I just treat it like terms. So I got, if I combine these two first, negative 21 and a, wait a minute. My answer says positive 5. No, that's right. Okay, so I got 6 and then 2q, and if I combine those, I get minus square root of 2q, which will leave me with 5 root 2q. All right, let's move on to 8. Ooh, fun. Okay. This is just a box problem. I mean, it's just factoring. We got to keep track of some stuff. So make a nice big box because there's lots to write here. Okay, and then we got a 5 and a 4 square root w. And then a 25. And a negative 12 root w. So as I times these together, I'm going to get 125. Here I'm going to get 100 root w. And here I've got negative 60 root w. And then here I'm going to have the negative 12 and the 4 is a negative 48. And then the w squared, or the square root of w times the square root of w is just w. So I've got, does it say to write it in a specific way? Nope. 125, combine like terms. These are the same. So 100 minus 60 is plus 40 root w. And then go to minus 48 w. The answer on the test writes it as negative 48 w plus 40 root w plus 125. It is descending order as far as your exponents go, so that's okay, but either one of these should work just fine. Okay. These ones I'm simplifying. So I'm timesing my coefficients, so that gives me 24. And then I can combine everything underneath the radical. So 13 and 4. Well, let's just keep it as 13 times 4 because we're going to have to undo it anyway. And then I've got end of the third and end of the fourth, so that gives me an end of the seventh. This breaks up as 2 and 2. So there's my pairs. 13 is prime. It's a lonely loner. So I'm going to multiply the 2 and the 24, so that's going to give me a 48. And then the 7, 1, 2, 3, 4, 5, 6, 7. There's a group, there's a group, there's a group. Or you could just do 7 divided by 2 is 3, so n to the third. And then you do have our lonely loner. So you got 13n. And we're good so far. All right, let's go on to the next one. Okay, when we rationalize a denominator, if there's two terms like there is in this one, you do need to multiply by the conjugate, which means when you take this 4 and then 2 plus square root 19, we get a times by the conjugate is kind of like a difference of squares situation. We're going to minus square root of 19. I need to do the both of them here. Square root 19. So what's going to happen is if we did the box method, which not a bad idea. So that gives me a 4, gives me a 2 root 19, gives me negative 2 root 19. And this one is just 19, or negative 19, sorry. These cancel each other out. And then 4 minus 19 is a negative 15. So that's my denominator now. And then I'm going to distribute. Well, let's just write what we've got. We've got 4, and then we're timesing it by 2 minus root 19. Let's see, this is 12. We're up there. Oh, yeah. And really, this is what the answer on it says. I'm sure if you wrote 8 minus 4 root 19 over negative 15, that would probably be good too. So, yeah. Okay. All right. There's a couple ways to do this one. I don't know if one is better than the other, but you could put this all under one radical. P to the third, Q to the sixth. And we could simplify under the radical before we do anything else. Honestly, that's probably how I would do it, just so there's less I have to find the square root of. And that's not right. This should be the sixth. Okay, so if we simplify, those go away. So still got here. Plug in 640 fraction, oops, wrong button. 640 fraction 250. And that's going to give me 64 over 25. And then up here, I'm going to have P, and then it's the 7 minus the 3 because I'm dividing. So that's going to be P to the fourth. And now I can take the square root of all of it. Square root of 64 is 8. Square root of P to the fourth is just P squared over 5. There are multiple ways to solve that one. If you wanted to take them individually, kind of work it down, you'd come up with the same answer. I think that's the easiest way, is simplify first and then take the square root. Okay. This one, because this is even, I can't take the even root of a negative number unless I want to get into complex numbers or imaginaries. So this one is just not a real number. Okay, this time we're doing cube root. If we wanted, we could split this up. 64 times cube root of m to the third. And the reason why I might want to do that is these will cancel each other out. So I got m as part of my answer, and then I could plug in the cube root of 64 to my calculator. Or, I know this is 8 and 8, and then that's a 2 and a 4, 2 and a 4, that's a 2 and a 2, 2. So I got, and my index tells me how many I need in each group, so I am taking the cube root. So 2 times 2 is 4, so I just get 4m. All right, honestly, this one is one I'd probably just put into my calculator. So you can do that if you want, or it's negative, so the answer is going to be negative, and I could change this into a radical form, so I'd have negative 343. It is raised to the first, but I'm just taking the cube root of it, and that's how I'd put it into my calculator. I think this is 7 and 49, or negative 7, negative 49, so you could go negative 7, negative 7. Which is going to give me negative 7 is my final answer. And you could just plug this into a calculator. Let me kind of show you how I would do that. Camera. So I got to do this and look through the screen at the same time, so bear with me. So I do have a negative, let's see, let's try this again. Third, and then second, and then it's that button, which is the radical, you choose whatever one. So that's saying cube root of negative 343, just click enter, negative 7. All right, let's go to the next one. I would write this as a radical. I mean, you honestly could just put this in your calculator. In fact, let's just do that. So it's 16 to the 5 fourths. I can show you how to do that one as well. We got 16 and then raised, and I would put this in, just put it in parentheses just in case. 32. So the answer is 32. But if you didn't want to do it that way, you could change it into a radical. So it'd be, let's see, 16 to the 5th power, and you're looking for the 4th root. So it'd be the 4th root of 16 times 16 times 16 times 16 times 16. I'm looking for groups of 4, so there's one. So I already got that. If I break this down, I've got 2 times 8, which is 2 times 4, which is 2 times 2. So the 16 times the 2 will give me that 32. Just do it on a calculator. It's easier. Okay. This one I'm taking to a power to a power. So if I have m to the 16th, I'm going to be timesing that by 7/8. This is another one you could just put it into your calculator. You could call 16 as 2 times 8, and then you're timesing it by 7, and then you're dividing by 8. So that allows you to, get rid of the 8s. So I'm just left with m to the 14th. If you did 16 times 7, then divided by 8, you'd get 14 either way. Okay, 19. We're just plugging negative 2 in for h. So I do have the 4th root, negative 7, negative 2, minus 14. So the 4th root of 14 minus 14. And then the 4th root of 0, well, that's just 0. Okay. Once again, you can simplify before or after. Really doesn't matter. But if you wanted to simplify before, this 12 and over 16, put it in a calculator, simplify it, but it's 3/4. And you got x to the 11th, y squared. So 3x to the 11th over the square root of 4x squared, 4y squared, excuse me. 3 is not going to break down at all. The x to the 11th, that's going to be x to the 5th. And you have 1 left over, so you got 3x over square root of 4 is 2, and then square root of y squared is just y. Let's see, is it 21? No, it's 20. Yep. Okay, we need to... Okay, there's kind of a lot on this one. We could simplify our fraction before. Yeah, let's just get rid of everything. So 64 is a perfect square, so it is 8. We'll still have to divide it by something. So maybe we'll just do 64, then we do our fraction, 450. Make sure I plug in the right number. So we're going to get 32 over 225. So that's going to leave me, and then if I simplify my C values, I got 7 on top, 6 on bottom, so that just leaves 1 on top. And then my D's go away. They get rid of each other. So really, we took it from something that looks like a lot to something, to me, is a lot simpler. Okay, and so we got square root of 32C over square root of 225. So if I break 32 up, that's 16 and 2, that's 4 and 4. It's going to give me 4 root 2C over, it's divisible by 5, 225 divided by 5 is 45, which is 5 and 9, 3 and 3. Got my buddies, and so really 225 is a perfect square, and so 5 times 3 is going to give me 15. Get my final answer. Okay, so this one you need to write in terms of I. The big thing that we need to remember is let me get a better color. Oops. Let's go here. I'm going to use this one a while. I is equal to the square root of -1. So this is an imaginary number. One of those things that I'm not the biggest fan of the name, but it is what it is. So I can rewrite this as the square root of 28 times the square root of -1. Now I know that this is just I. That's going to allow me to break this down to 4 and 7. This is 2 and 2. So I've got 2 root 7 I, which is the way it's written down in the answer key. Just be careful when you're writing it down in this format, because you don't want the radical to extend over the I. I'm not taking the square root of I. I personally would probably write it like this. And if it marks you wrong for writing it that way, I'll probably fix it. Now, there are some questions specifically that want you to write it in standard form, and those ones you do. This is fine. Those are more when you have an I as a variable. Okay, so these are the fun ones. So these, when you have I is just equal to I. It's equal to the square root of 1. But when I have I squared, well, that equals -1. And that just equals the square root of -1 times the square root of -1. Well, the squareds go away because you're multiplying them. Well, it's more like this. Square root of -1. And that's squared. So it goes away. You're left with the -1 on the inside. Then you got I to the third, which is equal to I squared times I, which is just -1 1 times I, which is negative I. And I'll rewrite this so that it's a little bit smoother. But and then I to the 4th is just I squared times I squared, which is just negative 1 times negative 1, which is a positive 1. So long story short, I equals I squared equals negative 1, I to the 3rd equals negative I, then I to the 4th equals a positive 1. And then it repeats, I to the 5th. So that's what it's getting at here, is if I take 91 and I divide it by 4. I'm using long division here. Well, that goes in 2 times, so that's an 8, right? I bring down the 1, well, then let's see, is it minus here? 2's 4, and then a minus, that gives me a 1, and then I bring that down, and then I get another 1. So that goes in, not quite, it goes in 2 times. And so that gives me an 8 again, and I get a 3, and there's nothing else to bring down. This is my remainder. So I to the 91st is equal to I to the 22nd. Well, 22 times 4 is going to give me 88, because it goes in that many times. And then times I to the 3rd. Well, because 88 is divisible by 4, it's a repeat on I to the 4th, which is just 1. And then I have I to the 3rd, which is equal to negative I. So this is my exponent, the remainder. So I like to do it that way, but there's lots of ways to do things. So once again, the answer is negative I. Okay, so we're adding, so we're just combining like terms. So I got a constant, and then I got a complex. And so if I add those together, negative 4 plus 5 is 1. And then 16 minus 5i is plus 11i. Now, this one does specifically say write this in standard complex form, which is the I is last. Technically, 11i plus 1 is the same, but it wants it in this format. So don't write it that way. Okay. Here, once again, it's asking for that standard complex form, but we're multiplying. So I got negative 9, 8i, negative 2, negative 13. So that's going to give me 18, negative 16i. And this negative 9 times 13. Oh. So it's a negative times a negative is a positive, and it's 117i. Then 8 times 13 is 104, and it is a negative 104, then I squared. Okay, but what does I squared equal? Well, it equals negative 1. So negative 104, wow, that's not right. Negative 104. And then because I squared is negative 1, well, that's just a positive 104. So I got 118 plus 104. And then I combine those two. That's going to give me a 101i. Add these together. I got 222 plus 101i. And what number is this one? It's 25. Wait a minute. It's not 2. That's not a 118. That's just just 18. So that's a 122. There we go. Sorry if I scared you a little bit there. Kind of scared myself. Okay. Write the answer in standard form. So it doesn't want I as a denominator. So we're gonna times this by a conjugate. And what that does is it's going to get rid of the middle terms, and it's going to turn it into I squared, which is going to make it a whole number. So I'm going to add 10i, and then 13 plus 10i. Because if I do it to the top, I also need to do it to the bottom. You're just timesing by 1. Here I can put this in, I can distribute. And I am going to write the I, let's see, I'm going to write the I last. So 2i times 13, that's 26i. But I'm going to put the other one first. It's 2i times 10i is 10i squared. And the reason why I did that is I've got negative 10, because the I squared is timesing by negative 1, plus 26i. Okay. And then let's do this bottom one. And I can do the box method. I think it's smart. So I got negative 13, negative 10i, negative 13, positive 10i. So 13 times 13 is negative times a negative, so it is positive 169. And then this one's going to be 130i, negative 130i. And then this one is going to be negative 100i squared, which is going to change it to a positive 100. So if I combine all my like terms, those go away, and I've got 269. Okay, again, this isn't standard form. Standard form is that a plus bi, and so all we really need to do is go negative 10 divided by 269, and then it has a minus, which is, okay, negative 10. What is it? Negative 26. Oh, this should have been a negative, you guys. So that does change this to a negative 26. I don't think it changes anything down here, because I wrote it right down here. Okay, scared myself a little bit. And I'm minusing 26 over 269. Now, the answer key does have the I out here, which is the same as negative 10 over 269 minus 26i over 269. This is one of those ones without playing with it. That's how it's marked. This should be right. I think it's in the right form. Come talk to me if it isn't. But if you can remember, put it in this form, where the I is kind of out on its own on the right. Okay. We did this one in class, but I'm going to do it again just because I think it's a good problem. And it's good practice. I'm going to combine these two first. So I'm going to have 7x plus 3y minus z equals 13, negative 4x plus 5y plus z equals negative 14. The reason why I'm combining these is it gets rid of the z's. So it gives me 3x plus 8y. The z's go away, so that's going to equal negative 1. I'm going to write this up here. 3x plus 8y equals negative 1. So I used equations 1 and 3. I need to use equation 2 somehow. So I'm going to write equation 2 down here. So I got x plus 9y plus 2z. And what I'm going to do is I'm going to take equation 1 and times it by 2. And the reason why I'm choosing that one is I already have a negative z. I need a negative 2z because I want to cancel out the z's again. I could use 3, but I would need to times it by negative 2. It would work, and you'd have no issues. You just got to keep track of a little more, which is just fine. This is still equals 19. Need that part. So here, when I times it by 2, that's going to give me 14x plus 6y minus 2z equals 26. Give me 15x plus 15y equals 45. So write it up here. 15x plus 15y equals 45. Now I need to get another variable by itself. So I'm actually going to take this one and I'm going to times it by -5. And the reason why I do that is it's going to give me a negative 15x minus 40y equals 5. And then I got negative 25y equals 50. Divide by negative 25, divide by negative 25. So y equals 2. So here I got y equals, oh, it's a -2. Okay, so now because I know what y equals, I can go and plug it into one of these two equations. So I have 3x, wait a minute. My answer key says y is 2. Where did I make a mistake? Not -2. I write something down wrong. That's a positive. That's a positive. It's 45. X minus 9y is 2z. I did this right in class. 14x plus 6y minus 2z is 26. Let's see. -15, -40, which is -25. Let me check that. 10 minus 40 is a -25. Should be a -1, so it's negative, it's +5. Is that a typo? I feel pretty confident about that, but I could have made a mistake somewhere. All right, sorry about this, guys. Let's see. 1 and 3. Make sure I wrote down everything right. 13, -1. Well, that looks good. 3x plus y equals -1. So we take number 2. It's 2z. Times that one, so I got 14, 6. It's 26. 45. All right, I might have to pause the video and come back because I need to figure out if it's wrong or where I made my mistake. So I'm going to pause that. Might have to make a part 2. This one's getting pretty long anyway.